Section 10.3 is where we're going to add and multiply radicals. This first part is where we're just going to practice adding them. So the first problem has you doing 6 square roots 11 plus 9 square roots 11. As long as these radicals are the exact same thing, you can add these whole numbers. So it would be the same thing as if I said, what is 6x plus 9x, you would tell me add the 6 and 9. So that's what you would do. You would add 6 and 9 and get 15, and then the x would stay the same, so same thing with the radical. So I would have 15 of those square root 11s. On the next one, you are subtracting. So the first thing you want to notice is that there is no number in front of here. So just like if I had an x with no number in front, I would realize that there's an invisible 1 because I have one of those square roots of 3's. So this is asking me to do 1 minus 5. So when I do that, I get negative 4, and then my square root of 3 just tacks on the end. So I really found that I have negative 4 square root of 3's. Okay, you try and do the next set. So on the next set, on the very first one, you have 7 square root of 2 minus 8 square root of 2, so you should be getting negative 1 square root of 2, which you could also write as just negative square root of 2. And then for the second one, you have 5 square root of 5 plus 2 square root of 5, so you should be getting 7 square roots of 5. So the biggest thing is making sure that you're adding the whole numbers and keeping the radical part the same. So make sure the radical doesn't change when you're adding. Okay, so then the next set is, what happens if the radicals are not the same? Can I do anything with them? So remember that the number underneath the radical part has to be exactly the same, and in this case it's not. So currently I would not be able to subtract those. But we did learn that we can simplify, so you may want to check to see if these radicals would simplify. Can I break down 3? Well, if I did, it'd be 3 and 1. No pairs there, so that would not break down. Can I break down 12? Yes, 12 will break down as 4 and 3. 4 breaks down as 2 and 2. So since I got a pair of 2's, it comes out. 3 stays underneath my radical sign. So the square root of 12 can be wrote as 2 square roots of 3. So if I substitute that back in, I now have 5 square root of 3 minus 2 square roots of 3. Notice now that my radicals are the exact same. So now I can combine them and subtract. So 5 minus 2 is 3, and then square root of 3 stays the same. Okay, let's have you try the next two. So on the next one, we had 4 square root of 7 and 2 square roots of 28. The square root of 7 will not break up because it would be 7 and 1 with no pairs. But the square root of 28, I could write that 28 breaks up as 7 and 4, 4 breaks up as 2 and 2, so with this pair of 2's it would come out, the 7 would stay underneath the radical sign. I still have that 2 out in front, so when I simplify the square root of 28, I get 2 square roots of 7 that I would need to multiply with the 2 that was already in front. So I would have 4 square roots of 7 that this piece would simplify to. So then I can add them now because they have the same radicals. So then I would get 8 square roots of 7. Okay, this next one is the same deal, except the difference is that both of those will actually break up. So I have 5 square roots of 32. I broke up 32 as 2 and 16, 2 and 8, 2 and 4. 4 breaks up as 2 and 2. Then I went through and paired up my numbers. So I had a pair of 2's there that came out. I had a pair of 2 there that came out, and then this 2 stayed underneath my radical. Then this 5 is still in play, so that's going to drop down to multiply with it. So I would get 20 square roots of 2 for what this simplifies as. Then I would do the same thing on the second expression. 18 I broke up as 2 and 9. 9 I broke up as 3 and 3. So this pair of 3's would come out, and then the 2 that's left over would be staying under the radical. The 4 now comes back in play, so when I multiply it with the other whole number, I get 12 square roots of 2. Now noticing after I simplified both of those expressions, they do have the same radical, so now I can subtract them. So I would end up getting 8 square roots of 2. So just like when we were adding expressions with variables, x's, x squareds, x cubes, they have to be the exact same in order for you to add them. So same thing with radicals. I have to have the same radical in order for them to add.